We are rolling. Alrighty. So the afternoon rolls on here at NOTACON. Thank you all for attending some of these wonderful talks. I hope you're having a good time. If you're not, let us know and we'll see what we can do to change that for you. But otherwise, let's keep on rolling. Trevor Reiter is a graduate student from Bowling Green State University and has a deep interest in digital audio and music as they pertain to computer science. He also likes to lay on a couch, eat Funyuns, and play video games. This talk marries both these things. Today, he's going to talk about using the Wiimote for making music, or at the very least, making annoying sounds to piss off your neighbors or roommates. We all like doing that. By the end of this session, you'll have a good idea about how you could use a Wiimote to your musical arsenal. Also, he wanted me to mention that Trevor started his career as a rule-breaking heel, tagging with fellow Texan Dick Murdoch to form the tag team, the Texas Outlaws, in the American Wrestling Association. In 1974, Trevor turned face after turning on tag team partner Pac Song and manager Gary Hart during a match in Florida against Eddie and Mike Graham. This led him to break out as a solo face superstar, primarily in Florida, referring to himself as Stardust, the White Soul King, and the American Dream, a working class hero. Ladies and gentlemen, Trevor Reiter.
I didn't think you'd actually do that. That's so sweet.
I have no shame, man.
Okay, so first off, I think I wanted to answer the question why you would try doing this. And I wanted to mention like Rock Band and Guitar Hero, right? So from a video game perspective, I think Rock Band and Guitar Hero are excellent ideas, right? They're fun games. But from a musical perspective, I think they're horrid, horrible ideas. And I'll tell you why this, and I'll fight you outside in the hallway if you disagree with me on this one. Because if you play through Guitar Hero perfectly, you get 100% or whatever on your, 100% perfection, you have no gestural, you're not performing any human gestures in that music. You play it mechanically, 100% through. You have no other way to play it other than what's programmed in there. So from a musical standpoint, I think that sucks. From a video game standpoint, I think it kind of goes along with the rest of the video game paradigm. So when I want to do a talk like this, I've been doing a lot of work in my graduate studies and making music with the Wii remote. But I started off with the question of why can't we make music with video game controllers instead of trying to emulate things like guitars? And so I wanted to mention a guy by the name of Jeffrey Stolle. And he's an electroacoustic musician. I believe he's out of Oregon, in an art college in Oregon. And he wrote a piece called Things I Do With My Fingers. And it is mind-numbing. It's 20 minutes long, and it's a little hard to bear through the entire thing. But it is neat because he's taking these video game controllers and he's putting gestural human information through them and using that to tell a story. It's a visual and audio composition. So as he's shaking the Wii remote and twiddling his fingers, visualizations of him like brushing his teeth and all these things he's doing with his fingers and sounds that go along with it are played along. So there's this human gestural thing going on with a video game controller I think is really neat and could be used for music. So straight out your blister pack, if you pick up a Wii remote, you get 11 discrete buttons. The power button does not count. It's actually a special function to turn on the Wii, right? So you get sensors on 3 axes of movement, and you get an IR camera and Bluetooth connectivity. And that's some good stuff for a human interface device. So with those 3 axes of movement, right, you can tell pitch and roll, but not yaw. So you can move, think of a marble on a china plate, right? That's kind of weird visualization. But if you have a china plate in your hand and you move it up and down, the marble moves up and down. If you move it side to side, the marble moves side to side. But if you could spin that plate on a stick perfectly, the marble would stay in the center and no information, the position wouldn't change. That's why you can't tell positional information rotating about the axis of gravity in the Wii remote. And that's actually why Nintendo chose to use infrared sensors instead of putting a I can't remember what it's called. It slipped my mind. A gyroscope. You would actually need a gyroscope to tell that rotational information about the Y gravity axis. And so about that IR camera. It's kind of an IR camera, but you're not peeking in your neighbor's window at 3 in the morning with it, with a computer. More specifically, it's actually sensing light blobs. So I need everybody to go back to your high school biology classes and put on your pseudopods and think like an amoeba for a second, right? So if you can recall for 1 minute, then the amoeba doesn't have any eyes, right? But it is able to sense light. So if you have a flashlight, if you close your eyes and you have a flashlight, you can sense a directional light in a position, but you don't know what the hell it is, right? That's kind of what the infrared sensor on the front of the Wii remote does. And so the Wii remote can actually sense up to 4 positions and track their locations. And believe me, this is no end to the really shitty puns of the Wii for reiterating the point. But, you know, there's a whole barrel of really bad puns to go from. Now, just to reiterate what we're getting at, you can get the discrete button info, the accelerometer information, the infrared information, and those are the human interface tools that we're going to use to build our instrument. So first, we got to talk a little bit about connectivity, right? So let's talk about the Bluetooth. You must get a Wiimote compatible interface, Bluetooth interface. Now that's kind of a weird thing to say because it's very generic. But the problem is the Wiimote is a very finicky device, and so it only works with some Bluetooth stacks. Now there's some safe adapters you can look at on wheelie.org that it has a good safe list that I can go off of, and I actually found one off of that where I got mine. If you have a MacBook or any of the Mac built-in Bluetooth, those work really well or are safe to use. But the problem is that depending on your operating system and your Bluetooth stack and how you're doing it, that's going to dictate exactly how you're going to connect the Wii remote. So I don't really have the time to go into every nuance of that. So instead of talking about the stacks and stacks like Tony Montana would talk about, we only got a half hour. But if you have Windows, like what I'm using, I have a thing called Blue Soleo, the Blue Soleo Bluetooth stack, and that works beautifully. If you saw me connect it, it was literally a one-click connection. If you have a standard Windows Bluetooth stack, it's just like adding a new piece of hardware each time. So it takes like 3 or 4 minutes, and that can get kind of graining on your brain. But I also used it on Linux for a while, and I was able to just write a script to pop it and automate it. So that's kind of a plus too if you're using it on that. So if you haven't seen me when I turn it on, it literally is as easy as hitting 2 buttons on the Wii remote, clicking on my Wii remote, and then hitting connect. So I'm going to talk a little bit about this thing called Pure Data, which is an audio programming language. Now, for anybody, is anybody here familiar with Pure Data? One, maybe? Okay, that's good. I wasn't expecting anybody to even know what it was. It is an audio programming language made by Miller Puckett to make DSP processing really easy and quick for people that aren't familiar with regular programming paradigms. So we're going to use Pure Data, this programming. It's free, by the way. I'll get into that in a second. But it's going to let us take the information from the Wii remote, and we can either output that through our sound chip, just like what I'm doing here and sending it back to there, or we could actually hook up a MIDI cable or a MIDI interface and take output from that and make all sorts of, run our synthesizers that way. So some of the benefits of Pure Data, it is free, which was the #1 reason for me using it. And it is cross-platform. There's ports for most major platforms. And it's made specifically for MIDI and synthesizer work, and for people who aren't really familiar with programming paradigms. And it also has Wii remote objects that we can place directly in our code. Now, when I say place in it, it's interesting because Pure Data, the programming environment and sort of the sandbox environment are the same thing. It's an interpreted language, so you can play with it, add things, change things, and still keep it running. And that really helps out when you're developing DSP. So this is a patch that I had written just a little bit ago, a couple days ago maybe, and it's a mess. And I apologize if you've never seen this before. This probably looks gross as hell. But I'm going to go through this, and I'll make sure this looks a little bit familiar before the end of this presentation. So you might be saying, oh, shit, that looks horrifying. And you're right, because if you saw that list there, I didn't say it was easy to learn, and there's a reason. But there are some simple audio tools that we can use when we're making our instruments, right? So we have oscillators. We can run sine waves or square waves or triangle waves, things like that. We can make noises like that. Or we can load sound samples into a buffer, or we can use basic mathematical calculations to form our own sound samples. And we can easily manipulate MIDI data in and out. So this is a little simpler patch that I'm actually using in the thing that I wrote today. And if you see over here, I just have one thing called a sound filer. It's reading one command, and it just reads the sound file in there. And then I'm able to use this object over here that says tab play to read this array, which I referenced as drums. And it was easy as that to just play back a sound file by sending information, like the play message, through a pipeline. Now, information is passed through these lines we see here. You can think of those as like information pipes. Now, this is the actual Pure Data interface for Windows. Now, other objects are available for different operating systems, right? But for Windows, we're going to be using something called WeSense. And actually, you just drop the DLL in your library of objects for pure data, and it comes up. You can pop it right in. Right here's my WeSense object, and I'm unpacking the data from that WeSense object. And you can see the three to the left, I have three outputs there. Those are my three axes of information. And the giant line of Fs over there is the output for my discrete button information. So it was as easy as that to put this into a programming environment and grab the information. And this is just a better illustration of the discrete button presses. These little things here are called toggle switches, and as you press buttons, the little X's will show up in them. And I can demonstrate that after this presentation here. So going back to this original thing that I written a couple days ago, I wanted to look at some of these objects. This thing that says PD Wiimote is actually a subpatch. Now I can create a patch or an object by typing PD space and then the name of that object, and I can create these little abstractions. It's like patches inside patches. So instead of having everything laid out in one giant mess, I've wrapped up that Wiimote patch, that WeSense patch, in a block, and I'm only taking the information that I want to use, which is the three axes of movement, the A and B button, and the 1 and 2 buttons. And then I have some other patches that I'll get into when I demonstrate the patch live, that I'm doing some number manipulations and some sound synthesis on the fly. Let's talk a little bit about the number formats coming out of the WeSense object. Now, the accelerometer values are actually, oh, I got something in my eye. The accelerometer values are normalized to gravity units, negative and positive, depending on direction. So you get three accelerometer numbers, those three number data sets, -1 and 1, if you're just rotating. But if you force it real hard, you'll get that force in G's. So if you force it real hard, you can get if you can throw 4 G's, you'll get 4 G's in that direction. All the buttons have Boolean 1s and 0s. So if if the number button is on, it's on. If it's 0, it's off. And I'll get into that change thing in a second when I demonstrate the whole patch. So basically, the pattern of use that we're going to be doing is that we're identifying some form of input that we'd like to use with. Right? So we've been over how the different modes of input on the Wii remote, but we're going to apply that to certain parameters of digital music. Now, that could be things like the frequency of the oscillators, or the position in a sample table, of where your playback is, so you can control playback speed, things like that. And it just sounds really boring when I'm talking about this, but when you hear it live, you can see that I'll be imparting some sort of gesture to it. And of course, we could send MIDI data. Or another example I had here was just moving a filter, like a wah pedal. So if you had like a notch filter for frequency, you can move that up and down. Now this seems like a horrible stretch to go from, but please bear with me for 1 second, right? When I first saw this painting by Jackson Pollock, I was probably in 8th grade, maybe high school, freshman year. And when I first saw it, I thought it was complete trash. Because I thought to myself, how could you call that art? It looks like a mess. But as I got older, I realized that when you see a painting like that, it wasn't the fact that what it looks like is one thing. But one of the important things about a painting like this that Jackson Pollock did, and most of Jackson Pollock's work, was that there's this gestural information that's imparted in the image. So he was doing things like poking holes in paint cans and throwing them around the room, right? And then rolling sand up in his paint, and then letting it drip on the floor in interesting patterns. And so when you look at it that way, there's all this human gestural information that makes a painting really interesting, and it brings a certain humanity out in it. And I'll get to the point of that in a second. But I did want to show off my patch. So here's some free samples. I'm going to pass this around. You're going to mess with this while I talk. So going back to that rock band thing, right? So in Rock Band or in Wii music, you only play back what's already written there, right? And you have no gestural information that you can add to it, except for maybe the wah bar on the guitars, right? But you have no musical gesture information, really, that you can add. And that's what I think is missing when you think of, these video games as musical instruments. I don't think you can think of them as musical instruments because there's no humanity and no gesture in it. Now, let's see if I can. If you hold down the B button, I think Josh knows. Right. So I'm going to sort of explore this patch, and I can't see it on my screen, so it's kind of awkward for me. You can see I just put that Wii Sense object here, and I'm grabbing the accelerometer information right here. And so the first thing I have is when you hit the A button, it throws according to the position of the Wii remote, it will play a small oscillator and then put an envelope on top of that. Sort of like it's a hit, just like a quick sampling hit, according to a frequency. Now that's not, it isn't spaced out in like note pitches. It's just, 300 hertz, 301 hertz, 299 hertz. It's not really musical, but it is an idea that you can put gesture and impart that in a sound. You can see whenever he hits the B button, a little X shows up, and that can tell you and help you debug when you're using something like Pure Data to do this. That sound sample is actually the Price is Right failure sound. That noise right now is actually a low-pass filter which is getting hit by both an oscillator and white noise. And so as you would move it around like that, you can get sort of a swirly effect. And that, if you hear those little guitar note things, those actually aren't samples at all. That is an implementation of the Car plus Strong string pluck string algorithm. So that's entirely synthesized. So I'm not running that through any external hardware or anything. That's just running on my tiny little netbook. And so you're able to leverage the information of other people that have done, people's work that they've done with Pure Data, like this Car plus Strong algorithm. I was just literally a drop in, and I was able to use all that information. And so that really noisy part in the end with the, it sounds like the pig squeal, I loaded the Price is Right failure sound into my sample bank over there with the loose horn. And what I'm doing is whenever that button gets hit, it does a playback at a certain frequency. And so it plays back those samples through that sample bed at differing rates. And it looks like a mess, but as you shake it around, you can jostle up the playback speed, and all of a sudden there's this gestural information on that. It isn't just straight playback. So I know this is kind of a small crowd, so if there's any questions, I'd love to answer or head up. Any idea? And does this look confusing to anybody? What's up?
I'm curious more about the IR.
The infrared.
Do you need any other equipment, or is that all you need?
Okay, the question was asking about the IR feature, and do I need any extra equipment, or is that all I need? Well, the thing is that for the particular Windows implementation of the Wiimote object in Pure Data, the infrared information isn't passed. That isn't part of the driver. One of the problems with the Windows implementation of this is that the Wiimote driver, whoever made it, just sort of abandoned it in progress and left it as a work in progress, and nobody can get a hold of them. But if you use the Linux version or other things like that, what happens is all you need is an infrared LED, and you need one that's sizably strong. I would recommend one that's probably 200 milliamps of power rating, and maybe a wider degree of radiation. But really, any infrared source will pick it up, and it'll immediately start getting information output from those outputs. The actual Wii video game system has two blocks of infrared information that are averaged to sort of be in the center of your television. So that's why you have that little light bar. There's two groups of infrared LEDs. So that really is all you need. Is just, you can actually use two candles if you'd like. If you have a dark room, turn everything off. You can move you get that information by putting a candle or two candles lit up. Anything else? Yes, back there. Do you have a question?
Thank you. Yeah, I was curious about how many of these devices could you play simultaneously?
This particular one can take 4 simultaneously. Jeffrey Stollett's piece, he actually uses 2, one in both hands, and all he uses is the accelerometer information. He's shaking them around. One of the neat things about pure data, though, is that you can network computers, right? And so you can put 4 on one laptop, 4 on another, 4 on another. You can chain these things up and send that information back and forth. So
right.
Really, it's unlimited.
Right, so you can port it through Open Sound Control,
Yeah,
for
absolutely,
instance.
absolutely.
Okay, cool.
Anything else? Could I help? Well, going back to the, if nobody has any other questions. I'm sorry, was there another question? Yeah, sorry.
Actually, I just thought it's something that would just be cool in general. Maybe in your free time, like set up like a virtual drum set so that when you have like 2 Wii-motes, you can play the drum like that. That'd be awesome. Like if you did that, I'd like to know, just because it'd be like cheaper than a digital drum set.
Oh, so the question is if you could build a digital drum set on that, and that's kind of what the Wii drums is doing, except for the fact that you're only playing back portions of a given drum track, right? But it's you could certainly try to do something interesting, and maybe it wouldn't be a perfect digital drum set, but you can do something with how if you hold a certain button down and you put a certain force in a certain direction, it plays a certain drum hit. So you're almost creating a new drum instrument where you could play something and learn it yourself, just in a small airspace. And of course, you could also use the infrared information to get positional information, and you could quantize that. So if it's on this part of the Wiimote's camera, it would play this as opposed to this. Any other questions? Okay, so I just wanted to bring it back to that Jackson Pollock painting one more time, is that I believe one of the most important things in music and in art in general is the imparting human gesture. And so this seems really silly that we're using a video game, interface to make music. But in another way, I don't think it is that silly, because we're still doing the same thing that many artists do. We're imparting human gestural information and making something. And so I'd like to leave you with that, and thank you for coming out.